Hi everyone. To know what's torque and how to rotate an object, watch this video. I'm Ibrahim Mutawa and this is Physics. Before we talk about torque, we need to remember the difference between translational motion and rotational motion. In translational motion, the object moves from one location to another, just like this boy changed its position from point A to point B. On the other hand, rotational motion is when the object rotates around an axis. Actually, the axis is at its center of mass. An example of this gear rotates clockwise and this gear rotates counterclockwise. They don't change their positions, instead they are in a rotational motion. An object may have both translational and rotational motion, just like the wheels in this bicycle. As it moves from A to B, their positions change in a translational motion. Also, in the same time they are rotating, so they have both rotational motion and translational motion. Also, we need to remember what's force. Force is the ability to accelerate an object. To accelerate an object means to change its velocity. On the other hand, torque is the force of rotation, which means it's the ability to angularly accelerate an object, to give an object an angular acceleration, which means changing its angular velocity. Look at the disk in this simulation. This point is its center of mass, which means when it rotates, it will rotate around an axis located at this point. When I apply a force on this disk, it was at rest and then gains an angular velocity, which means it angularly accelerates. Also, when I push here another force to stop the disk from rotation, so its velocity changes to 0, which means it accelerates too. But it's a negative acceleration, or we can call it deceleration. But remember, it's an angular acceleration or angular deceleration. So the force makes an object rotate. One more thing, when I apply a force like this on this disk, it will rotate. But when I apply a greater force like this, it will rotate faster, which means it gains a greater acceleration, which means a greater torque. So when the force increases, the torque increases and vice versa. Now let's see what are the other factors that affect torque. We use the symbol tau, it's a Greek letter, to represent torque. We learned that torque is directly proportional to the applied force. When force increases, torque increases, and vice versa. In this simulation, I have two objects with different masses. Their center of mass is here, which means this is the axis of rotation. When this system of two objects, when it rotates, it will rotate around this point. If I push at the center of mass, or I push at the axis of rotation, what will happen? No rotation at all. Now, if I push away from the axis of rotation, like this, now there is a rotation, but they rotate slowly. If you want to increase their torque, I need to move my hand away as far as I can from the axis of rotation. In this case, it will rotate faster. So we can conclude that torque is directly proportional with R, where R is the distance from the axis of rotation to the point where I apply force. So we conclude that torque is directly proportional with F and R together. Now let's talk about our daily life example that everyone uses. Opening the door and closing it is applying torque to it. By applying the relationships we found in the simulation, pushing the door at this point close to the doorknob, easier to open the door, a greater torque than pushing at this position, because the axis of rotation is at hinge. So as far as you go from the axis of rotation, you increase the distance. So this R is smaller than this one. For this reason, we all push the door at the doorknob. We are using the doorknob and push the door, not from the hinge. And not in the middle. It's going to be harder to move. It will rotate, but with a smaller angular acceleration. Now, this is the door from a top view. This is a closed door, and this is an open door. Now, let's discuss the angle where you exert your force. Of course, the door represents R. So this is the distance. This is called R, and this is the axis of rotation. Here is the axis of rotation, axis of rotation, axis of rotation, and this is R. Okay, if you apply your force perpendicularly like this, at 90 degrees, when theta equals 90 degrees, you get a greater torque. So the torque is maximum at this point. If you apply the force at an angle, the angle in this case, theta, is less than 90 degrees, but it's greater than 0. In this case, torque is not maximum. It got some value. Okay. Also, if you push the door with a force at this angle, which is the angle between, which is greater than 90 degrees but less than 180. Okay. And finally, if you try to push the door this way, finally, if I'm trying to push the door from this side with a force that comes parallel to R, which means theta equals 0, it makes 0 angle with R, or 180, both of them, the door will never open. Okay, so the torque in this case is 0. As you can see from all these data, the torque is directly proportional, not with theta, but with sine theta. And we are saying that because we know that, so if the angle is 0, sine 0 is 0, and if the angle is 90 degrees, sine 90 is 1, which is the maximum value. And again, when it reaches 180, it becomes 0 again. So this is the function. You see it's maximum at 90 degrees. When we push at the door perpendicularly like this, it gets a maximum torque. And if we are pushing from this side, which means the angle is 0 or 180, let's say if you push or pull from this side, it will never rotate. Okay, just like here, 0 and 100, so 0 and 180, sine 0 and sine 180 both equals 0, which means no torque at all. And between 0 and 90 or 90 and 180, it will be some value between 0 and 1. Okay, so finally we can find that torque is directly proportional with F, directly proportional with R, directly proportional with sine theta. The proportionality constant is 1, so torque equals F R sine theta. Force is measured in Newton, the distance is measured in meters, and sine theta is dimensionless, so the measuring unit of torque is Newton times meter. Work and energy are measured in Newton times meter too, but work and energy are scalar quantities. So Newton times meter, we use joule to represent it. Okay, so we cannot use joule as a measuring unit for torque because torque is a vector quantity, not a scalar quantity. Also, R sine theta is called the moment arm or the lever arm. So what's lever arm? We use L to represent the lever arm, capital L, like this. So L from the previous equation equals R sine theta. It's the perpendicular distance from the axis of rotation to the force line. How can we do this? Let's see. Now look at this door. If we are trying to open it and we apply a perpendicular force, a force that is perpendicular on it, like this. So this is the force vector, and this is R, the distance from the axis of rotation to this point. We can see that the lever arm in this case is from the axis of rotation to this point. This is L, which in this case equals R. So L equals R if theta equals 90 degrees. And you can see that sine 90 equals 1. In this case, L equals R. So what if we are applying our force at an angle, not at 90 degrees, but an angle like this, theta. So this is the force, and this is R, and this is the angle between them, theta. Now the distance from the axis of rotation, as you can see, R is not perpendicular to F. In this case, we need to draw a perpendicular line from the axis of rotation to the line of F. In this case, we need to extend the force line like this, and we need to draw a perpendicular distance from the axis of rotation to F and try to make it as perpendicular as we can. So this is looks like a perpendicular distance. So it makes a 90 degrees with F. And now this is L. if we use the geometry at this right angle triangle, we know that sine theta equals the opposite divided by the hypotenuse. The opposite of this angle is L, and the hypotenuse is R. Hypotenuse that faces 90 degrees. Okay, so R. Cross multiplication, you will find that L equals R sine theta, and this is lever R. So finally, we can say that torque equals F L, which equals F R sine theta, and measured in newtons times meter. And this is torque. Thank you.